All right. Now that we've talked about the now next rule and we know what a geometric sequence is, a sequence where we go from one term to the next by multiplication or division, we're going to talk about two main formulas. The first is the explicit, the first is the recursive formula, and the second is going to be the explicit formula. The recursive form comes from the now next rule. It's just that instead of writing next and now, we write a sub n and a sub n minus 1. Now, we've talked about this before, but just as a reminder, a sub n is equal to the nth term. So it's the term we're looking for. So a sub n minus 1 is the term before the nth term. So for instance, if we're talking about the fifth term, that's our n, 5. Then the term before the fifth term is the fourth term. So that's a sub 4, 5 minus 1. Okay, so just to keep it in mind, when we talk about terms, we're talking about the numbers in a sequence. If I have 1, 2, 4, 8, 16, then 1 is said to be our a sub 1, 2 is our a sub 2, 4 is a sub 3, and then so on and so forth. All right. So keep this in mind when we talk about terms. We're talking about the numbers in a sequence. All right. Keep that in mind. Numbers in a sequence. All right. Back to it. So in this problem, we're asked to write the recursive form to describe the pattern below, then use it to determine the next term in the sequence. So, all right, we have 2, 6, 18, 54, right? If we want to write a formula in recursive form, we would write a sub n equals a sub n minus 1 times, that dot means times, 3. And this is our recursive form. And you're like, what does that mean? Well, to find the next term, a sub n, we take the previous term and multiply it by 3. Isn't that a true statement? Right? So this is like next equals now times 3. So now we're formalizing. I'll make that up. Made that up, but we're formalizing the rule, the now next rule. So with number 9 here, we're going to write a recursive rule, right? We're given 5, 10, 20, 40. Well, to go from 5 to 10, we multiply by 2. 10 to 20, we're just making sure it's consistent. And they all are multiplying by 2 to go from one term to the next. So we know that our common ratio, we say R, is 2. So to write our formula in recursive, we say a sub n equals a sub n minus 1 times 2. And we're done with it. What does that mean? Take our now times 2 to get our next. All right? That's all it means. All right? So, one other thing I want to say. Suppose you're like, how do we find this common ratio? I mean, you seem to do it so well, but I might not be able to determine it right offhand. All right, that's what this note is for from the previous notes. All right, the previous section. To find the common ratio, we take our second term and divide it by our first term. So here, 10 divided by 5 is 2. Hey, common ratio. Right, common ratio. Right? And so I'm going to skip here to 11. Right? We need to write a now next rule. We already know a sub n equals a sub n minus 1 times, well, what is our common ratio? Well, we take 300 and divide it by 600, right? And what is that? 0.5 or a half, right? Whatever you want it to be, all right? And there we are. Now you complete 10 and 12. Okay? So now to the explicit form. We use the explicit form when we want to find the nth term of a sequence. Particularly, it can be as near or far away from the pattern that we see. So it could be the 20th term or the 50th term in the sequence, meaning the 50th number in the pattern, right? If we want to find that, then we're going to use this explicit rule, a sub n equals a sub 1 times our common ratio to the n minus 1. All right? So we have here, we have, write the explicit form to find the nth term. And then it says find a sub 8. So we're given the pattern, same pattern that we've been using in this example, 2, 6, 18, 54, right? So if we don't know the common ratio, just take that 6 and divide it by 2. We know it's 3, right? So we have our R, all right? So we got our common ratio. All right, we also need to have our first term in the sequence, meaning the first number, and that is 2. So that's A1. So A1 equals 2. And now we can write the explicit form to find the nth term. And it goes a little something like this. A sub n equals 2 times 3 to the n minus 1. Just like that. All right. And to find the 8th term in the sequence, so this is just to find anything, right? We got our formula. But to find the 8th term in the sequence, we're going to substitute for n 8, all right, and find the 8th term in the sequence. So this becomes a sub 8 equals 2 times 3 to the 8 minus 1, or we say to the 7, all right, to the 7. Now, we're going to take out our calculator. It could be Desmos. It could be whatever you like. All right. I'm pulling it up. All right. And I am going to put in here 2 times 3 to the 7. And my answer is 4,374. That is the 8th term of the sequence, A8. So this is the first answer, first part of the answer. This is the second part of the answer. All right. So what about 13? We already know our common ratio is 2. And we know that from number 9, right? We said R is 2. Our first term in the sequence is 5, A1. So now to write our formula, we have A sub n is equal to 5 times 2 to the n minus 1. All right, that's our formula to find the nth term. All right, and then next it says find the 9th term in the sequence. So we substitute for n, 9, and this becomes A sub 9 is equal to 5 times 2 to the 9 minus 1, so just 8, all right? It's the term before the 9th term. So we're going to go into Desmos and plug this thing in like we know how. So we type in 5 times 2 raised to the 8. And the result is 1,280. So here's our answer for the first part. And here's the answer for the second part. Now I want you to complete 10, 12, 14, 15, 16.